All right, Peter, I show 6 o'clock. Are you good to go?
Perfect. Thank you.
You're welcome. Okay, so everybody, thank you so much for joining us this evening at HMSC's Virtual Science on Tap. I know we're not all together at the new Marine Studies building or even in the Rogue in Newport, but I hope you're someplace comfortable with some good food and drink while you listen to our presenter tonight. My name is Cinnamon Moffett, and I'm the Research Program Manager at Oregon State University's Hatfield Marine Science Center, located in Newport, Oregon, and I will be your host for this evening. Wanted to just remind folks, if you haven't joined us for a Science on Tap before, this is a webinar format, which means you do not have control over your mic, camera, or screen share. But we do ask that you put any questions into the chat box, which you can find by clicking the little button that says chat, either at the top or the bottom. You'll get a pop-up screen and you're able to put in chat questions there. I hope you do that at any time throughout this talk, but we'll work through those questions at the end of tonight's presentation. Also wanted to let folks know we're recording tonight's event, and that will be posted in a couple days on our past seminar page. I'm going to put that link into the chat so you can find the chat, but also so you can see the link. That way you can watch this again. If something goes by too quick, you're welcome to share if you would like to share it with others that can't join us. Also, once the recording goes up, there will be closed captioning. So if that is something that is helpful to you, the recording will have closed captioning. We're not able to do that live, but we can do that on the recording. Want to make a couple of quick announcements. So our next Science on Tap will be April 21st, when we have Mauricio Cantor, who's an assistant professor of the Marine Mammal Institute here at Hatfield Marine Science Center. We'll be giving a talk about how inventive feeding strategies and tactics shape dolphin societies. So very different topic than what we have tonight. So hopefully you'll be able to join us. And again, right now we're calling it a virtual event, but stay tuned. We might have the opportunity to have that on site. So also want to put in a little plug for the Hatfield Marine Science Day at Hatfield on April 9th. This event is also going to be virtual, so please save the date and join us online. We have all sorts of amazing live streamed events that will be happening, including a live shark dissection. So come and join us on April 9th. Virtually online. And if you need any information about any of these upcoming events, you can go to the HMSC or Hatfield homepage, scroll to the bottom, and there is a calendar of events there. And you can click on any event you want and you'll get more detail. You'll also get the login information that you might need. But for tonight, we're very excited to have Peter Rogerio here to talk with us about his work. Dr. Peter Rogerio is a professor with CEOAS at Oregon State University and is the director of the new Cascadia Coastlines and Peoples Hazards Research Hub. Peter has extensive expertise in coastal geomorphology, coastal hazards in both Washington and Oregon. And so we're really excited to have him here this evening. So Peter, the floor is yours. Take it away.
Thank you very much, Cinnamon. Really appreciate it. And thanks everyone for joining us this evening. So in this episode of Science on Tap, we're going to be thinking about the various ways in which Cascadia coastal communities are working together to increase their resilience to coastal hazards. And right from the beginning, I just want to point out that the theme of the talk will be that many of us feel that the best way to do this will be via the process of co-production. And by that, I just mean simply the deep and sustained collaboration and communication between all folks that are going to have a stake in these issues and do have a stake in these issues. And that includes homeowners, business owners, public officials at local, county, state, and federal levels, lots of NGOs, advocacy organizations, and hopefully not last, but not least, researchers as well. So, co-producing resilient coastal futures will be the theme of tonight's talk. Now, my students in my coastal hazards class that I've taught this past winter have kind of accused me of piling on with all the things that are happening in the world. But I do think it's useful to kind of start a conversation about co-producing resilient coastal futures by thinking about some of the issues that we do have along the coast of the Pacific Northwest, as the Cascadia coastline in general. And so I'll start out by showing just a couple of examples of the kinds of things that are being experienced along our coast. Many of you guys have maybe participated in, really successful science communication effort led by DLCD and others thinking about king tides and the experience that they have along the Oregon coast, and how that's kind of a little bit of a window into the future potentially with sea level rise in terms of our hazards. So this first video that I'm showing is an example of a high tide happening at the time of a big precipitation and river flow event in Willapa Bay in the Raymond, Washington area. This kind of image now in the middle panel, this is Rockaway Beach a couple of years ago during the king tide event, where we have water overtopping an area causing impacts to some backshore infrastructure. And then another video from a colleague, Jay Senewal at State Parks. This is from Salishan, again, a couple of years ago, showing the impacts of a high water level event, not necessarily during a significant extratropical storm, but there's a lot of factors kind of compounding together, causing overtopping and negative impacts to the backshore infrastructure. So these are kinds of coastal flooding events that we experience now along the Pacific Northwest coast. Obviously, these high water level events also drive a suite of coastal change hazards along the coast. I spent a lot of my time thinking about beaches and dunes. So these are images from beaches and dunes, but these are pictures taken from as much as 3 or 4 decades ago. The one in the upper right-hand panel here is an oldie but goodie. This is Cape Lookout State Park, significant coastal erosion during the 1982-83 El Nino. In the middle, this is Ocean Shores, Washington, significant dune erosion, endangering backshore infrastructure during the 97-98 El Nino. And clearly, I think many of us know that when infrastructure is jeopardized by erosion events and flooding events like I've been showing you, typically the response, the adaptation measure that we employ to deal with that has been riprap revetment along much of the coast. However, still, when we do employ those adaptation strategies, we have situations where it's not maybe designed for the kinds of conditions that are necessary. So we have breaks and need to repair that infrastructure. We also have situations like in the lower right-hand corner, a picture I've shown many times before, where we might be protecting a certain stretch of infrastructure from future damages of erosion and flooding, but we actually have some significant trade-offs and what that means for other things that we use the coast for, other ecosystem services that the beaches and dunes provide. In this case, a clear example of a lack of beach accessibility across this area during a high tide event. Okay, so these are the range of kind of coastal hazards that we experience along the coast, coastal change hazards. Now, we've experienced these, as I mentioned, in some sense for decades. We're kind of used to dealing with these, but we do know and we have a sense that these issues are increasing with time, getting worse and worse. And there are a whole suite of climate controls on really the changing coastal community resilience to coastal flooding and erosion. And these are the kinds of things that we want to be thinking about. So first and foremost, we know that sea level is rising. We know it's going to continue to rise, and that needs to be informed with our tectonic setting. I'll talk a little bit more about that throughout the talk. I showed some examples where some of the biggest erosion and flooding events occurred during our major El Nino events. And so we already know this, but we need to be planning for that kind of climatic variability at interannual to decadal scale into the future. And then just in general, trends and variability in storminess patterns. This could be simply thinking about what the wave height patterns are doing, but potentially more complicated things like the compounding events that are associated with atmospheric rivers, high precipitation and river runoff events happening at the same time as, say, high tide events and big wave events, and what that might do to coastal change. So we need to be thinking about those climate controls on coastal resilience to flooding and erosion. However, actually, so I just want to show that I mentioned that sea level, obviously is rising, and just to bring people up to date with kind of the latest rates of global sea level rise. This is basically the complete satellite record to date, showing that rates of sea level rise globally are about 3.4 millimeters per year over the last several decades. And that's about double the 20th century rate, which was about 1.7 millimeters per year. So not only is sea level rising, but those rates are accelerating now. Just showing a little bit longer time scale, we do know that for long periods of time, sea level was relatively stable prior to industrialization, but it was kind of after global industrialization began, late 1800s, early 1900s, that sea level rise acceleration started. Again, I mentioned that 1.7 millimeters per year of rise over the 20th century. We're here in about 2022 right now, where we've accelerated to about double that 20th century rate. And as of about 2 or 3 weeks ago, these were the most authoritative projections of global mean sea level into the future. You can see a huge range of variability from about a foot to upwards of about well over 8 feet or so, kind of really depending upon the emission scenarios. And so these are products that were used for design, for adaptation planning, for measurements, but really thinking about the range of emission scenarios and what that would do in terms of driving future sea level into the future. One sort of piece of good news that I can bring you tonight is that in the latest projections that just came out, this new publication by Sweet et al. 2022, these are the most up-to-date now projections for global mean sea level rise. And you can see that highest end scenario has been pulled from this projection out to 2100. And so while we might eventually reach that high rate of that high value of 8 feet or so of sea level rise sometime during the 22nd century, it's very, very low probability during the 21st century. So the projections, at least the uncertainty band has narrowed somewhat, but that is still a huge band of uncertainty from about a foot again to about 6 feet of potential, really kind of dictated by emission scenarios over the next several years to decades. Okay, so that's what we can expect in terms of sea level rise, and then how that will actually impact our flooding and erosion along our coastline. I mentioned the impacts of El Niños, particularly the major El Niños. And so those high water levels that we experienced during El Niños, I used to say that we would experience basically decades worth of sea level rise during a particularly extreme El Niño season. It turns out now with acceleration of sea level rise, it's really only about a decade of sea level rise. But that's a big issue. We have scenes like this along our coast during those major El Niños, larger wave heights than typical and anomalous sediment transport patterns. So both the flooding hazard and the shoreline coastal change hazard becomes more significant. And one of the big questions we have is what is the potential of climate change inducing a change of the magnitude and frequency of El Niños into the future. And while there are some studies like the one I'm showing here that give some indication that there's a potential for major ENSO events to double in frequency into the future, this is one of many studies, and several of those studies show exactly the opposite. So this is very much a research question that is still unknown. But really to think about planning for the future of our hazards, we need to be thinking about the possibilities of major El Niños increasing and potentially decreasing. And one last climate control that I mentioned is, I think most of us know that, living along the Oregon, Washington, Northern California coast, we have one of the most intense wave climates in the world. And we are also very sensitive to the potential changes in storminess patterns that climate variability and even climate change will bring. And so while maybe a decade ago or so, we were worried a little bit about whether or not just wave heights were going to continue to increase. We had seen a trend. We now see that there's a lot of significant interannual to decadal variability, but there are lots of other issues associated with potential changes in storminess, the angle with which the waves reach our coast, the period changes, and then, as I mentioned earlier, the compounding nature with precipitation. All these things need to be looked at in terms of our future hazards portfolio. So these are the climate controls on our exposure to a lot of the chronic hazards that we've been dealing with for decades. I'd be remiss if I didn't mention that, of course, we also live in the Cascadia subduction zone. And so we're also having to prepare for the really, really big one. And so I borrowed a couple slides from my colleague, Dan Cox here at OSU, who likes to show this picture, this oblique image of the seaside coastline, and then overlay that with what occurred during the Tohoku event in Sendai, Japan in 2011, and really similar scales of processes, scales of the photograph to kind of get a real image of what a major Cascadia subduction zone earthquake and associated tsunami might look like for our coastline. And so we really need to be thinking about both the chronic and acute hazards along our coastline, unfortunately. And just a reminder, and again, I think probably most folks in the audience, realize this, that we've only had a fairly deep understanding of Cascadia subduction zone science for a handful of decades. So this kind of knowledge of this event is relatively new. It's also, unfortunately, due. The last event was 322 years ago. And these things are, we do experience these kinds of large rupture events every 300 to 500 years. It's a huge event. And so, part of the reason why we study the entire Pacific Northwest, the entire Cascadia coastline, is because that's the footprint of this event from Northern California, well into the Canadian coastline. And truly, to be resilient to this acute hazard, we need to seriously increase the ability for life safety during this event. And there's been a huge amount of effort over the last couple of decades focused on this, but also lots of effort needed in terms of just generally increasing our ability to absorb and recover quickly. Okay, so just a brief rundown of the hazards that I think we all know that we experience along our coastline. And with this background of climate-driven changes in coastal community exposure to coastal hazards, as well as knowledge that while we have done a lot already, we still have a long way to go in terms of preparing for the really big one. I'd like to tell you tonight a little bit about a new project that was funded by the National Science Foundation and initiated about 6 months ago. And so the Cascadia Coastlines and Peoples Hazards Research Hub, or the Cascadia CoPes Hub as we call it, it's a collective endeavor with research collaborations and advancements that are involving over 50 researchers across all the organizations that you see listed here with these logos on the screen. And there's also many, many coastal communities across the Cascadia region that are involved in this effort, ranging from Humboldt Bay in Northern California to the Salish Sea along the Puget Sound of Washington. So I've been lucky enough to be a leader of this effort, but there's also lots of other folks on the leadership team, both at Oregon State University and the University of Washington. And we have a much larger steering committee as well that involves every member of these organizations, a suite of community liaisons, and lots of interactions with coastal communities, okay? And so the overall vision of this effort, of the Cascadia CoPes Hub, is to contribute to socioeconomic viability and equitable resilience in the service of coastal community identities, needs, and values through a series of targeted advances. And again, that'll be a theme throughout tonight. There's clearly has been a lot of work that's been going on, and we're leveraging a lot of that work and trying to fill in some of the gaps with targeted scientific advances. A second part of that vision is to inform and enable integrated hazard assessment, mitigation, and adaptation, including comprehensive planning processes, policymaking, and engineering, and all, as I mentioned from the beginning, the theme throughout the talk, co-produced and sustained collaboration with many coastal communities. All right, so the hub is organized around 5 interconnected teams. And this diagram to the left here kind of expresses how those teams are kind of working together. And here I'll just list those teams. We have a team focused on tectonic geohazard sources, integrated probabilistic modeling. So a science team focused on primarily on the acute hazards associated with living in the Cascadia subduction zone. A team focused on exposure to inundation and coastal change hazards. So a science team more focused on the chronic coastal hazards of erosion and flooding. A team made up primarily of social scientists focusing primarily on community adaptive capacity. A team focused on broadening participation and inclusive STEAM education. And then finally, a team focused on community engagement and co-production of coastal hazards knowledge. And so the project also, and I'll tell you a little bit about each of these individual teams and how they work together, but the project also tests 2 overarching hypotheses. And the first is that fundamental advances in convergent coastal hazard science will have the ability to transform our understanding of the risks that the coastal communities in Cascadia face. And that an inclusive co-produced approach to advancing hazard assessment and mitigation will increase coastal communities' adaptive capacity and broaden participation in achieving an equitable and just disaster risk reduction. So that, as I mentioned, the hub builds on many prior and ongoing collaborations to address previously identified research needs for Cascadia coastal communities. And many of those ongoing efforts are in areas that we refer to now as collaboratories. And those are these kind of blue ovals that are highlighted on the map here on the right. And so these are areas that many of us have had long-term either projects or relationships with various coastal communities where we've kind of already started some deep dives in. And we're going to continue to do that and adapt our hub research strategies to address emerging needs with these interactions with the collaboratories. Now, there are also several aspects of the hub research that will address the full Cascadia coastline. And in some sense, the identified collaboratories are just kind of a place to start with some of our kind of deeper engagement efforts. So one of the approaches where we're starting to have some of our interaction with coastal communities is via some listening sessions. And we actually just had one about 2 weeks ago. There was hopefully some of you might have participated in it. It was a virtual listening forum that was focused on improving healthcare access in disasters. And that was led by Nicole Arrett of the University of Washington and several others. And it was attended by about 75 folks. And as I mentioned, it was just a couple of weeks ago. Just a couple other quick points as we carry out this work that I've been talking about. The hub is also tackling a series of grand challenges that have been identified by the National Academies and the National Science Foundation in Earth Sciences, probabilistic modeling, inclusive science education, and science and risk communication. And so I'm going to be kind of, as I said, kind of walking through some of the detailed plans that the hub has. But I just want to point out that there are plenty of opportunities to get involved, and we're going to have lots of engagement throughout the process of this project. But I have our website listed here, as well as an email address that people can contact us. And if we haven't reached out to you already, or we don't in the next few months, feel free, please, to, if you're interested in getting involved in some of these efforts, to contact us via these methods. All right, so for the remainder of the talk tonight, I'm going to tell you a bit more about what we are initiating with the project and a little bit more about how you can get involved. Since we're only about 6 months into what's going to be at least a 5-year effort, I'm going to try to sprinkle in a few examples of some ongoing work that started prior to the hub's initiation as well. All right, so at the heart of what we do, and really you can see the heart of this graphic here on the left, is our community engagement in the co-production of ideally usable coastal hazard science. We'll start with just describing what this Team 5 is all about. And I guess hopefully just by the nature of this diagram, I should have said explicitly, every member of the hub, well over 50 researchers, students, postdocs, et cetera, all participate in both Team 4 and Team 5 activities. It's not just a handful of meeting facilitators. While we have professional facilitators, it's every member of the hub really focused on some of these efforts. Okay, so what is Team 5 all about? Listing the overarching objectives here. I'm not going to read all of them, but one of the key ideas here is to engage coastal communities, especially some underrepresented communities and populations that have not necessarily been involved in some of these efforts thus far. And we want to identify, as I mentioned, some science research priorities that respect community values and the protected value assets in the community. We're going to, as I mentioned, build upon and leverage past and current coastal initiatives. Many folks have been working on this stuff for a long time, and integrate the expressed needs and interests of the communities within the hub research. And then, try to build networks. We really take the hub part of this seriously. So building the networks of self-involved community members and expanding the number of potential future participants in a range of these processes. There are a lot of kind of detailed ways that we are already starting to initiate this kind of engagement, and I'm just going to tell you about a few of the more exciting ones. And so what I just have listed here on this slide are kind of some of what we call the co-production models that we're going to be using. For example, there's a variety of kind of co-production studios that we've employed or will employ, and these include things like some structured modeling workshops where we can work with a particular community, and we've done this in previous projects where we explore a range of potential alternative coastal futures, a range of adaptation pathways, and work together to kind of develop a suite of potential policies and scenarios that we incorporate into some of our modeling efforts, and then explore what that means in terms of increasing adaptive capacity and increasing coastal resilience. There's also a handful of folks that have developed asset and value focused community planning and design studios. So these are things like courses at the different universities that might go to a community and focus on a design project for a quarter or a term. Things like multi-use benefits of vertical evacuation structures along the Washington coast is an example of those kinds of community co-production studios, and lots of other examples that hopefully will be developed over the next couple of years. Another really creative aspect of this approach that we're excited about kind of rolling out, we've hired several already, but up to 4 postdoctoral fellows per year that are going to be working in various aspects of the Hub's research. Will be spending about 50% of their time as direct community liaisons, working with and responding to some of the needs that come up in our discussions with the collaboratories and the community. So while this is not necessarily a consultative relationship, it allows us to help address some research priorities and questions that come up in our discussions. Another exciting thing that's going to start happening, I think, towards the end of year 2 and get rolled out in year 3 is the development of a Coastal Leadership Institute, where the goal is to build adaptive capacity through an expanded network of collaborators. This will involve the development of two-way teaching and learning and co-created curriculum, and will focus on developing leadership and capacity in a cohort of hopefully over a dozen folks per year when we start rolling this out. And again, if folks are interested in that Coastal Leadership Institute, feel free to get in touch and can be part of the development of it. So there's a handful of others, but I just wanted to focus on those. And then kind of move to Team 4. Another key aspect of the Hub is, as I mentioned, to try to broaden participation. And we're doing this at kind of all levels, working with different groups in the collaboratories throughout Cascadia that haven't been involved in this conversation before, but also in terms of some of the students that we are hiring and training to try to really broaden that participation to different kinds of groups. And one of the coolest things that we've just kicked off is what's referred to as the Cascadia Charter Undergraduate Fellowship Program. So that's the Coastal Hazards and Resilience Training, Education, and Research Program. And this is really going to be focused on enhancing the university kind of sophomore to junior experiences of underrepresented and minority undergraduate students. And so we just this past quarter put out the first kind of call for applicants for this program. And we had well over 50 applicants to join, went through a process in terms of figuring out who the first cohort will be. And we actually have 10 students that have just kind of initiated a process. They're going to start their orientation over spring break. And these folks will be involved in research, outreach, and engagement, and basically all aspects of the Hub. And this is the potential to be a multi-year effort. Once they go through the first year of the program, a new cohort will come on. They'll help train that second cohort. They'll participate in Hub researchers' labs, et cetera. So we're pretty excited about that. There's a few other efforts as part of the Broadening Participation Team 4 efforts that'll happen. The Cascadia Teach program will actually go to some coastal high schools and try to bring some research and experiential-based knowledge that the folks in the Charter Undergraduate Fellowship program are developing, and actually work with some teachers and high school students. And then some trainings that originally the idea was it would be for graduate students, postdocs, early career faculty, but I've seen some of the ideas that have been listed for these trainings, and I think all of us are going to want to participate in those. So those are the ideas for Teams 5 and Team 4. I did want to spend a little bit of time talking about some of the science plans as well. And so I mentioned Team 1's focus is on tectonic geohazard sources, integrated probabilistic modeling. So there's 2 overarching goals of this effort. And again, just want to stress, many of these tasks have been ongoing for a while along the Cascadia coastline, but again, with something so complicated, so important, so new, there's a lot of details still to be worked out. And so a lot of these kind of fundamental science programs need to be ongoing. One thing that I'm particularly interested in is kind of updating our estimates of vertical land movement, based upon our tectonic setting. That's what this product here on the left is trying to get at, is the alongshore varying rates of vertical land motion that occurs basically, again, due to our seismic setting. and thinking about how that might trickle down in terms of being impacted in terms of relative sea level rise along our coasts, what that means in terms of co-seismic subsidence during Cascadia subduction zone events, et cetera. The second goal is scenario simulations, and there's a variety of aspects along here, and I'm just going to hopefully demonstrate some of this with a quick video. Hopefully you'll be able to see a little bit of this. Sometimes doesn't translate great over Zoom, but the idea is to develop a suite of integrated state-of-the-art simulations. Integrated meaning, thinking about the earthquake itself, the landslides that potentially are generated by these earthquake events, the tsunamis that movie just played, and then some of the built environment response as well. So developing a suite of integrated state-of-the-art simulations, and then I'll move down the list here. And then some of the things we can do with that information is develop multi-hazard impacts of both the shaking and inundation of these events on coastal infrastructure. And so there's one aspect of the hub's work. We'll have engineers developing new updated fragility curves, basically our way of determining which buildings are at risk, with different loadings from the multiple hazards that are experienced during these events. And then just a third topic here that I've only just recently begun to appreciate. Colleagues here at Oregon State University, including Dan Cox, Joe Lewis, Jenna Tilt, have been starting to look at this in quite some detail. But basically the ability, if we can, to forecast the tsunami debris and what that means in terms of getting transportation corridors open quickly for recovery purposes and the islanding that might occur after events, and debris is quite a big issue that needs to be dealt with in a very careful manner. So that's just a very quick overview of what Team 1 is all about. I spent a lot more time talking about that, obviously. Team 2, as I mentioned, is focusing more on the exposure to the chronic hazards of coastal flooding and erosion, coastal change in different environments. And so, this is work that I've been intimately involved with over my career. And, it's quite clear that coastal communities along the Cascadia coastline still lack the necessary information to plan for increased flood and erosion risk. And hopefully I demonstrated that earlier with that huge range of variability of potential sea level rise issues, as well as the other climate drivers. And so our goal is to really develop and conduct integrated probabilistic studies in climate and hydrodynamics to quantify the exposure to coastal hazards under both present and future different kind of climate conditions. We've had a lot of really nice approaches that we're bringing to the table on that issue. And then it's not just about the flooding, a lot of different kinds of environments. I mentioned sandy, open coast, bluff-backed or dune-backed and bluff-backed shorelines before, but we also have muddy embayments. We have mixed sediment glacial environments along our Cascadia coastline. And so can we develop approaches to describe the likely impacts associated with morphological change, and then some of the ecological resources and habitat loss, and how might that evolve with different climate change scenarios. And then finally, maybe most excitingly, I showed early on the example of hard engineering armoring, or riprap revetments being kind of the primary adaptation measure that we apply typically, at least along the Oregon coast, in the response of erosion and flooding issues. But more and more, we need to be looking at a range of other options. And one potentially promising avenue for that is to kind of think about and evaluate natural and nature-based features for adapting to various hazards and climate change. And so just a few additional photographs on that. One of the kind of the exciting possibilities is to think a little bit more deeply about the potential for dynamic revetments to be employed along our coastline. Now, this is an approach that tries to mimic some things that we see in nature, where we have not just rock large enough that it doesn't move with and basically reflects all of the incoming wave energy to protect backshore infrastructure, but in this situation, this cobble is small enough that it actually moves and is dynamic and moves with the hydrodynamics. The Oregon coast has been one of the pioneers in deploying these kinds of revetments, and the Washington coast has now picked up on this as well. And there's several really exciting projects along the Washington coast that we're learning a lot from as well. And so this is something that we're going to try to examine in a lot more detail. Ideally, getting down to even the development of engineering design guides for these kinds of projects. Now, maybe it's not inherently obvious to everybody, but coastal dunes where they exist along our coast, they're about 40 to 45% of the Pacific Northwest coastline. Is our sandy beaches are backed by coastal dunes. It's really the first line of defense in many ways to backshore flooding and erosion. We do manage our coastal dunes for a variety of different purposes. Sometimes we manage that for endangered species. Other times we manage coastal dunes, as in this picture here in Pacific City, for improved views and lack of sand blowing into the backshore. But there's also the potential, just think of dunes in general as a natural and nature-based feature for potential climate adaptation in areas where we might not necessarily want to have hard engineering structures. So we could actually potentially design the height, the width of dunes. We could think a little bit more deeply about the role that different kind of vegetation species plays in terms of trapping sediment and building foredunes and protecting backshore infrastructure, as well as keeping a connectivity so the ecosystems remain healthy as well. So that's another aspect of this part of the Team 2's effort. And then another one that I won't spend a lot of time on, there's lots of potential for these kinds of features to be employed in the kind of lower energy estuaries, et cetera. And Megan Wengrove at Oregon State University is leading this part of Team 2's effort. All right, so moving on finally to the last team here, really team focused on community adaptive capacity. The overall goal here is to increase the adaptive capacity of coastal communities to prepare, respond, recover from both chronic and acute hazards. There's a variety of ways in which we're going to try to do this. I'm going to give you just a couple of bullets about the research focus. So the idea here is to try to really integrate multiple worldviews and knowledge systems into how we think about risk assessment and management and adaptation. So this includes both working with tribes and potentially traditional ecological knowledge, but also working with people that have worked, played, lived along the Cascadia coastline for decades and have a huge amount of local ecological knowledge that can be brought to bear on the issues that we've been talking about. The second research focus is really identifying a suite of adaptation options, mitigation options that can enhance our kind of various forms of capitals that might be impacted and islanded during disaster events. And the idea here is to strengthen, obviously, community equity and livability, but this is really going to be an area of kind of close coordination with a variety of folks within the collaboratories, kind of thinking through what that range of approaches might look like. Another one is building capacity of local governance systems. So first and foremost, this is going to be a desktop exercise, of examining what exists right now in terms of governance systems, but then thinking through potential ways to implement equitable and just adaptation strategies and policies into our local governance systems. And then the final piece of this Team 3 effort is focused on refining and developing just decision support tools in general and our ability to test alternative adaptive capacity strategies. And so, while many times it really does take, going out on the coast and doing something and then seeing what happens, it's nice if we can actually do some of this with modeling and some computer software to actually think through what some of the adaptation pathways might look like. And I'm going to just spend a few minutes, I think we have some time, to talk a little bit about how some of this work has been ongoing along both the Oregon and Washington coasts for quite a while now. We've had over the years a couple projects focused at county scale. Most recently, a group of us have been funded by Oregon Sea Grant to kind of in general try to envision Oregon's coastal futures. And now we're expanding that obviously to the full Cascadia coastline. And we're thinking through in these projects a range of, as I've been mentioning, both chronic and acute coastal hazards. We obviously know where the improvements in infrastructure have occurred now, but we're actually incorporating landscape evolution and seeing how that, as population grows, how communities might evolve. By gathering community perspectives, we've identified a whole suite of potential policies and adaptation measures And we're obviously kind of thinking all this through in terms of trying to identify a range of multiple possible coastal futures. And the ultimate goal is having informed coastal communities. I think I just described this framework with that last slide, but basically these kinds of projects have involved a suite of hazard modeling, and that's both chronic hazards as well as the various aspects of acute hazard modeling. We've identified a suite of options and strategies that we can look at in these models, and then also with some of our work with coastal communities, some resilience metrics in terms of how to actually measure direct losses, indirect losses, whether or not we actually are achieving social equity with some of the adaptation planning and mitigation measures that are implemented when dealing with coastal hazards along the coast. And so these are the kinds of scenes that we've had over the years where we're trying to develop, with the folks in different locales, the kinds of issues that they're dealing with now, how they might like the coastline to look in the future. We've developed a suite of, as I mentioned, different policies, grouped them into different scenario narratives. I know I'm moving through this relatively quickly, but we've explored, what it means to think about a suite of policies that might, just simply protect backshore infrastructure, like, what we often do in terms of building riprap revetments. But lots of folks have asked us to also try to examine a suite of policies that might be implemented that involve potentially changing human activities to suit the changing environment. So that might be, what we've called in our projects here, realign, but many folks around the world refer to this now as managed retreat. So are the ways we can implement policies that we're actually slowly pulling back some of our assets from the coastline. There's also a suite of policies that we've developed and tried to implement in some of our models where we're actually restoring ecosystems. So what I was mentioning earlier about some of those natural and nature-based features, that's where those construction of non-hardened shorelines might come into play. And then we always try to examine things relative to kind of the baseline or status quo. And so I'm just going to give, actually, this is just an organizational slide showing how, well, we have developed individual policies that might be used in terms of adapting to different hazards and try to increase resilience, increase adaptive capacity. We typically group them via different policy scenario narratives, so baseline, protect, realign, restore. We also look at a suite of different climate scenarios, and now, particularly with this new project, looking at a suite of potential Cascadia subduction zone scenarios and different kinds of policies that can be implemented in the landscape. So I'm just going to give one example from a project we did in Tillamook County several years ago, where we're basically looking at, thinking about the influences and trade-offs between what would happen with a coastal protection strategy going forward in terms of the trade-offs associated with recreation. And that's something that these kinds of kind of semi-quantitative efforts can actually help us explore. So we've developed tools and quantitative approaches that allow us to evolve the landscape such that we have a pretty good idea of where existing hardened shorelines are today. So that's this 2020 panel right here that I'm showing. And then with various triggers in terms of what sea level is doing, what storm patterns are doing, what maybe your neighbors doing along the coast, we see that the certain stretches of coast might become significantly armored if they basically adapt a set of policies that are focused on hardening or coastal protection. And so that's what's shown here with these panels now on the left-hand side. But again, these kinds of approaches can allow us to think through what the trade-offs would be. And so we've also developed, again, semi-quantitative approaches to think through how often a certain stretch of coastline might be accessible for, walking your dog, riding a horse, et cetera, across a stretch of coastline. And as you get into a situation like this, where water is impacting that hard engineering structure, you might reduce the beach accessibility. So we've shown this in maps with various different strategies that have been implemented. And so you can see if you actually pull back assets from the coastline, you have more beach accessibility than you do with the baseline scenario. Some people like to look at that in map views. Sometimes it's a little bit more intuitive to look at that in terms of time series views. So in this case, we're looking at the percent of shoreline armored. These are just, of course, these are model simulations. So please take these with a grain of salt. But looking at different policy scenarios going into the future, showing that what I just showed with the maps, that potentially if we're focused on hardening, we might increase the protection of backshore infrastructure. but obviously the armoring will increase into the future. But the trade-off there is reduced accessibility, and that might have impacts on the local economy, on the ecosystems of that region, et cetera. So these are the kinds of examples that we're going to continue on with some of the Cascadia CoPes Hub research, particularly in Team 3. The final thing that I'll say here, and I think I'm good on time, in terms of efforts that the Hub is bringing to the table here, is we have a series of themes that are really going to cut across every aspect of what we're doing. And you can probably imagine, based upon everything that I've said, we're kind of biting off quite a bit. So we're going to be focusing on both the spatial and temporal scaling across the acute and chronic hazards at a variety of time and space scales. We want to focus on our science communication, the translation of this information into usable decision support. And then finally, much of the work that we're going to be doing is going to be hopefully integrated and probabilistic modeling in terms of our simulations. The last thing I'll just say is that there are not just the ability for some of our co-production and engagement with stakeholders to develop some emerging research ideas, but there's actually a decent size of the budget that is going to allow for the project to actually evolve through time. And so we have funds set aside for special projects that will be reserved for this community initiated research activities. And so please be on the lookout for that in the future. All right, so I've talked a lot for the last 45 minutes. I'm just going to leave you again with our overarching vision here on the left, and just a little bit of a reminder of some of the things that I've said in terms of the kinds of activities that we started and that we plan on engaging with over the next several months, and then of course over the next 5 years. We have a really great monthly public-facing seminar series that has been ongoing now for months. If you are not on that list and you are eager to learn more about these issues, please, again, email at us at cascadia.copes@oregonstate.edu. We'll get you on that list because some fascinating discussions have taken place. We've started with some of our kind of collaboratory and listening sessions. I mentioned the one on healthcare issues from a couple of weeks ago. There'll be more of those, so stay tuned. I just mentioned the seed funds as well for community-initiated research initiatives, and many more opportunities as we go. And then I just want to again, say thank you for joining us tonight. Thank you, Cinnamon, for having me. I think we have plenty of time for a discussion now. And I just want to again point out lots of ways to kind of get in contact with me and/or our fantastic program manager, Ali Burgos, who will respond to this email at cascadia.copes@oregonstate.edu. Thanks very much.
Thank you so much, Peter. That was a lot of information really quick. I was going to say, take a breath and take a drink. For folks online, please put your questions in. Some of them are coming in just to me. Some of them are coming to everybody, but please put them in. And as folks are kind of processing their questions before I start reading some of these, Peter, I had a question for you just about, it seems like the focus of the Hub, at least for this first 5 years, is about research support or decision support tools, gathering information, pulling things together, finding gaps. Is there plans then in the future for implementation ideas? Is the Hub going to that place? Or are we really focusing this first little bit on gathering information for decision makers?
Well, it's a great question, and one that we've been asked many times before, and actually different projects as well. I mean, I think the bottom line, Cinnamon, is that implementation is happening all the time, right? So we're folks on the ground, whether it's individual homeowners, collections of homeowners, and state, local agencies. People are having to deal with these things on a regular basis. But again, whether it's an adaptation measure for a chronic hazard, or if it's kind of planning, evacuation, from a tsunami from a Cascadia event. So these I think the implementation happens always, and so I think ideally the research needs are kind of driven by conversations that have already been happening with the folks that are doing the implementing. And so I think it's kind of a collective learning that we're all going through. So I don't like to look at it, whereas we do work for 5 years, then hand over, or maybe we just then either switch gears and think about how to implement, or the implementation happens 5 years from now. A lot of this is just, you learn as you go. Decisions have to be made now. You try to always use the best available science. And so I think it's an ongoing process is kind of how I'd like to answer that question. That said, we have policy, public policy people on the team. We do have, folks that have that as part of their research portfolio. And so they're very interested in how decisions are made as well. So I think that it is the research of decision making is something that is being looked at as well as we go. But I think that there's going to be a lot of things where we are already had a lot of conversations with folks, and that has set the what we've done for the last 6 months to stand up a lot of the initial research ideas. But things are going to be emerging constantly.
Okay. Thank you for that. That gave me some framework to understand a little bit more about what the work is going to entail. I'm just going to start working through some of these questions, and everybody, I might jump around a little bit, but I'll try to get to them. The first one that came in kind of builds on what we were just talking about. It seems like most of these coastal communities will face, or most of the issues these coastal communities are facing are going to require some state legislation. Will you be proposing possible legislative solutions like better building codes?
I mean, it's certainly a potential possibility. I mean, I think there are lots of processes that are already in place for things like this. So, the American Society of Civil Engineers just released, Cinnamon, you know this better than I do, a couple of years ago, a new set of design guidelines for tsunamis, right? So that those kinds of things happen on a regular basis, and the state, different states employ those in slightly different ways for different kinds of projects. But so again, those conversations are happening, and I think folks in the hub might have some input into those conversations, and they have already. But I do think a lot of those conversations have been ongoing.
This kind of adds to that a little bit in a slightly different direction, but where do you see local land use planners being involved with your particular project?
I see that's a question from Guy. We'd love to have you involved, Guy. We're actually talking about this today on a slightly different topic, but thinking about coastal dunes and just the dune management issues that we experience along the coast. And the coastal planners are the people, I think, that hear every side of the story. They get earfuls from the homeowners that have issues, whether it's too much sand or not enough sand. But they also are thinking about policy changes and implementing strategies and want to know the best available science. So I think it's places like that where we're having listening sessions, prioritizing research needs and gaps. I've been working on coastal dunes along the Oregon and Washington coast for quite a while now, but we have a huge amount of research to still do in terms of getting to the point where we think we can, help with design guidelines for some of the management practices that are existing right now, whether we can actually design dunes to serve as coastal protection features, but also provide other ecosystem services. So, I mean, that is one example, Guy, specifically, because I was talking about dunes with lots of other folks today, where, local land use planners came up specifically, but I think there's probably several others.
And so I'm going to ask this other question, and then I'll just prompt you to tell us again how to get engaged. But I have somebody here who's asking, are you recruiting new graduate students for this project? And if so, how can I apply to join Team 2? So tell us how we can get involved.
Yeah, I mean, so I think there's a lot of, I don't know if I have a number for you, but I think when we wrote the proposal, we had about, 40 or so people involved. And I think right now our team is over 60 because we've hired some graduate students, some postdoctoral fellows. We have this new and fantastic cohort of folks that are joined as the first charter fellows set of groups. And so I think that the main thing is to reach out to the faculty that are involved. The universities have their application deadlines, but yeah, please just reach out to me in particular about Team 2 issues, and we can see what we can do.
Great. So we have a question, but before I ask it, can you define, you use the word islanding or isolate. Can you define that real quick for our audience? And then I'll ask this question.
Yeah, I mean, I think islanding has been an issue that folks along Cascadia have been talking about for some years now, and I think it means different things to different people. But I think after a major event where we have earthquake damage from this tsunami, issues associated with subsidence, liquefaction, et cetera, landslides, many coastal communities, be them rural or even some of the more urban coastal communities, might be cut off from a variety of different resources. And that's because some of the transportation pathways are cut off because of landslides. And so I think, the islandy concept is, first and foremost, just kind of physically isolated based upon, it's hard to get equipment and vehicles and recovery supplies, first responders even, into those communities. And so when I was talking about debris removal, that's, one of the kind of key aspects of hopefully, removing some of that islanding through time. Hopefully lots of folks have, followed the guidelines that emergency managers, try to promote in terms of 2 weeks ready, because, I think that's the thought, is you need at least 2 weeks of supplies before a lot of help might arrive. But you have that 2 weeks of supplies, but you still have to clear a lot of roads, clear a lot of debris to have more support. So I think that's what we mean by islanding, kind of in a physical sense. I think there's a lot of other potential psychological and cultural islanding that might take place as well.
So the question was coming in and asking, is there a map of the neighborhoods that will be island or islanding that will happen during Cascadia? And somebody put into the chat the Cascadia Island mapping project. So take a look at that. And if that doesn't answer your questions, Del, you could probably reach back out to Peter and move forward with that. Okay, so we have a question that came in about how can local homeowners tell their story about how the ocean is affecting their property? For example, in some areas, the riprap is affecting some things, but there's holes and it affects others. So how can local landowners tell their story?
Well, I mean, that's a great question. I think maybe talking to people like Guy Sievert and the local coastal planners, because I mean, again, those are the folks that will be implementing projects, or at least thinking about implementing projects. But please feel free to again reach out to our email address with the story. The more we know, the better in terms of understanding the different needs and issues that are occurring. We will be having a whole suite of different kinds of style events. Again, they might be virtual listening sessions, as we kind of phase out of COVID, but ideally we're going to be, coming to communities near you and having in-person sessions. And that's another great opportunity to kind of get involved and tell the story then. But I think, knowing what the problems are now is one thing, and then also kind of trying to envision through what we think we want the future of the Cascadia coastline to look like is key, and that's what we mean by kind of developing this suite of adaptation measures, mitigation measures, what have you.
So there's a question about, with the different groups that are involved in this, California, Oregon, Washington, and British Columbia. Can you talk a little bit about the different strategies the different areas are using, and if one is a little ahead of others in certain aspects of being prepared for these changes?
Yeah, and I'll probably stick to Oregon and Washington because I have my most experiences there, and then hopefully as we can develop the project as we go through the years, have a little bit more experience to bring from California and British Columbia as well. But here in Oregon, we have our land use planning goals, which really kind of dictate a lot of our development patterns. Goal 18 is the land use planning goal that really is focused on what can be done around beaches and dunes. It's a great success story in many respects. It also results in a situation where certain property owners don't have the ability to respond in ways that other property owners have the ability to respond. So that's kind of the Oregon policy setup that exists. The coast of Washington does not have a goal 18 land use planning goal. While they have a lot of policy guidelines where they really want to focus on non-engineering solutions first and foremost, there's no kind of rule prohibiting, if you weren't built before 1977, like in Oregon, you certainly can still protect your coastline. So that's kind of a fundamental difference in terms of the different states. There's also lots of differences in just simply the processes and the rates of shoreline change and the kinds of hazards that are being experienced. I mentioned that Oregon kind of got out ahead of much of the country in terms of building some dynamic revetments. Jonathan Allen's works for Dagami, the State Department of Geology, did a lot of that early design work. But now the coast of Washington has really kind of run with cobble dynamic revetments and is kind of pushing, I think, the national conversation and that kind of nature-based feature. They've also experimented a lot in Washington with sand fencing and dune building, much like other parts of the country does, in terms of trying to build up elevation, again, to use dunes to protect backshore infrastructure. That's something that we don't do on the Oregon coast. And again, there's some policy issues there. So I think hopefully that answers the question. It's just some of the differences. Just briefly, in Humboldt, there's a lot of kind of dune restoration projects that are occurring. There's a significant difference in terms of the climate, sediment supply, grain size, and so the kinds of habitat restoration areas that occurred down in Humboldt might be different than the kinds of things we can employ in Oregon and Washington, but we're trying to learn from each other as we go.
So there's another question. Thank you, Peter. There's another question, and it might be from somebody in your group. So I'll just say this out loud. They're asking whether there's a list of attendees tonight so that we know who is interested in today's topic. And I'll just tell you that Science on Taps on purpose are anonymous. So we do not have a list. That means that if you want to get more information, you will need to go ahead and contact Peter through the contact information that's on the screen. So if you want to get more involved, please do so by reaching out directly to him, because the attendees list will not be available after we get done. So just being really honest and open about that. Okay, I think I might have skipped a question. I'm going to jump back up to that and just ask you, are seawalls part of the conversations that you're having?
Yeah, definitely. Seawalls being, more or less kind of these vertical walls that are meant to protect infrastructure. They're really primarily deployed in our region in the Puget Sound, the Salish Sea, and the coast in the Washington area. And that's because of the processes, the environment, the energy level. Along the outer coast of Oregon, it's really primarily riprap revetments. I think there's a handful of vertical seawalls, but really it's not the primary measure. And it just that reflects all of the wave energy back offshore. Whereas I think even riprap revetments do dissipate some energy. So it's not the ideal solution for the outer coast anyway. It's certainly been used in more inland, lower energy environments. And
just on that note, if you are interested in seeing one of those lower energy environments at Hatfield on the Estuary Trail, there is a cobble revetment that has been in place for quite a while. So if you're curious about that and you haven't seen one before, there is one here. Okay, I might have missed some questions. So folks, if you have any follow-up, please reach out directly to Peter and his group. I apologize if I missed something. They were coming in kind of quick there for a little while. We are at our time. Thank you everybody for joining us. Peter, any last words for this group that you want to just kind of button up for us?
No, except that thank you very much, Cinnamon, for hosting this event. Thank you all for coming out on a Wednesday night. It's great to see so many people interested in these issues. And as I said, please reach out to us if you want to stay involved in what we're doing with the Cascadia CoPes Hub.
Great. Thank you so much. Thank you for inviting us in, Peter. I think a lot of us have ideas. I have all sorts of projects I want your students to come help me with. So that would be really great. Just a couple more questions are coming in. Again, thanks everybody for participating. Reach out to the Research Hub if you have anything. Peter, you're getting all sorts of thank yous and a great presentation. We really appreciate you spending your time with us as well. So everybody online, I hope to see you next month at our next Science on Tap. And Peter, again, thank you so much for being with us. For everybody, all right, I'll say good night. We'll see you next time.
Thanks, everybody.